Hello everyone, this is the Proteus design of our implemented AM transmitter circuit. Here the first block gives the 6 MHz carrier, the second block is the main modulation block, and the final block is the RF amplifier where both the current and voltage is amplified and then sent to the antenna. This is the real-time implement on PCBs. This is the output of RF amplifier block given a sinusoidal signal as input. Here I am changing the amplitude of the message signal and we can see the effect of amplitude changing on the output. If the amplitude of message signal increases, the output's amplitude also increases. Now we will see the frequency changing effect. If we change the frequency of the message signal, that is if we increase it, the signal shrinks, and here I am decreasing the frequency and the signal expands. Now we will see the bias voltage effect on output signal. If we decrease the bias voltage of the main circuit, the output's amplitude decreases as we can see, and if we increase the bias voltage, the amplitude increases as we can see here. The peak-to-peak voltage of the transmitted signal is almost 10 volt peak to peak, and we set the bias voltage around 12 volt, and this increased amplitude is transmitted through our antenna. This is our antenna, which is a loop antenna of 1 feet by 1 feet area, which accommodates 6 turns of coil. The amplitude modulated signal have almost 10 volt peak to peak, which is high enough to receive for the receiver circuit. Here our AM modulated signal is transmitted to our receiver circuit and is caught by their own antenna, and finally it is reached there.
Our circuit which we have implemented on the copper board. The first stage is the antenna, which is connected to the input port. This signal continues to the demodulation circuit, where it is demodulated with a very low voltage. The signal is then sent to the first RF amplifier stage, which has a amplification of about 5 times, and it is then sent to the second amplifier stage, from which we take the output to the speaker or the headphones. Over here you can see the modulated signal. As we change the amplitude is changing on the oscilloscope. At this point, after the input, the signal is passing to the demodulation circuit, and you can see the signal has been demodulated to a 1 kHz sine wave. Then it passes on to an RF amplifier stage and a low pass signal, and it is being amplified to this oscillator output. The signal is then being sent to another amplifier stage, and the output is as shown. The voltage over here is much higher, so we need to change the voltage per division on the oscilloscope, giving me a signal of this wave shape.
Here we are transmitting a sine wave from our transmitter circuit, and we can hear the tone caught by our receiver circuit in the speaker. Here this is the tone of our transmitted sine wave.
As we change the frequency of the sine wave, we can see that the signal is changing at the output oscillator signal as well as the pitch of the sound. Now we are changing the amplitude of my input signal, And on the output stage we can see that the amplitude is changing as well. And at the final output amplifier stage, the gain is as shown.
Now we will transmit our voice through a microphone instead of the sine wave. Here the input jack is disconnected from the signal generator and is being connected to the microphone. The positive jack goes to the microphone's positive port.
এখন এখান থেকে একটা ভয়েস দিচ্ছি আমরা EEE 09 সেকশন সি কমিউনিকেশন ল্যাব থেকে বলতেছি আমরা প্রজেক্ট করলাম এম ট্রান্সমিটার এবং আমাদের এম ট্রান্সমিটেড সিগন্যালটা রিসিভ করছে আমাদের সেকশনে আরেকটি গ্রুপ এবং ওই গ্রুপ থেকে স্পিকার থেকে ইভেন আমার শব্দ আমি যে কথা বলতেছি সেটা শোনাও যাচ্ছে। আশা করি আপনারা এখন আমার কথা শুনতে পাচ্ছেন। এখন ভিডিওতে স্পিকার দেখানো হচ্ছে এবং স্পিকারে আমাদের ভয়েস শোনা যাচ্ছে আমি যেটা পাঠাচ্ছি।